How do I measure and compare red light devices on the market as a consumer?
So for a consumer to measure and compare red light devices is quite difficult because the equipment required to do accurate measuring of red light therapy devices called spectroradiometers are several $1,000s. So a lot of times you want to rely upon the manufacturing details, reviews from the marketplace, and of course, most importantly, your own results with the device. Now, regardless of the output, regardless of the wavelengths, when you find your own device that is improving pain, that's improving your recovery, that's what every device is going for, and that's what's going to be your ultimate point of comparison.
Is a higher energy output better for red light therapy?
So it depends. Higher energy outputs are faster to get to the dose that you need. So in red light therapy, dose and wavelength are key. Dose is the amount of light received. So a higher energy output is the rate of output coming from the device times the time gives you the dose. So a dose is the quantity, output is the rate. So you can have a low output device over a longer period of time and have the same overall dose as a high output device over a shorter period of time. With that said, there are some sweet spots of irradiance levels, or the amount of light being emitted, this power output, but there's also not a lot of agreement on what these best power outputs are. If you're looking at mimicking the sun's power output in the red and infrared wavelength are right around 50 milliwatts. So generally speaking, if we pull it back to natural mimicry, you're looking at something right around the 50 milliwatt sweet spot, which I would say is a natural sweet spot. With that said, dose and wavelength are the true metrics. Power output is then the rate that you get to the dose.
Would you say that more LED lights are better?
So more LED lights, it depends on what your goal is. More LEDs will oftentimes give you a higher power output, which means achieving the same dose in a smaller amount of time. So if you want to dose your shoulder with 5 joules per centimeter squared of red light, and more LEDs can do that in 10 minutes versus less LEDs might do it in 20 minutes, then in that case, more LEDs is better because 10 minutes is more convenient. More LEDs also allow you to cover a larger surface area at the same time. So if you want to treat a specific spot on your back, you don't need a large surface area to treat your whole back. However, treating your whole back is often better than treating the small part of your back, because even the cells that aren't currently in pain can still benefit from red light therapy. So in a sentence, more LEDs gives you a faster time to achieve the dose and covers a larger surface area while you're using the red light therapy device.
Is a larger surface area more effective in treatment with red light therapy?
So larger surface areas are more effective at treating larger surface areas of the body, but are less important when you're trying to target a specific part of the body. So for example, if you have a wound on the back, a large surface area covering the whole back is good. Every cell of your body can benefit, but the important bit for healing the wound is going to be the LEDs that are directly over that wound. And so larger surface areas give you larger surface area outcomes, but smaller targeted devices are better for smaller targeted outcomes, especially in the context of we're buying a device, we're purchasing a device. So larger devices cost more, even if they're covering more and doing it faster. Smaller devices will cost less and are used for better targeted outcomes.
With red light therapy, is a longer wavelength better than a shorter wavelength in terms of pain relief?
So longer wavelengths go deeper into the body when you're using red light therapy. So the red light in red light therapy, about 630 nanometers, 660 nanometers, is primarily used for skin and sort of topical outcomes. So hair growth, skin care, wrinkles, acne, topical capillary growth, stuff like that. Whereas longer wavelength, typically in the near infrared range, so 810, 850, 950, 1070, these wavelengths go deeper into the body and are better for things like musculoskeletal pain, are better for things that are happening in our gut, and then over 1,000 nanometers are better for things that are happening in our brain. So in a sentence, the longer the wavelength, the deeper into the body it goes. So depending on what it is that you're using red light therapy for, will also really determine what wavelengths are best for you, whether that's red light and skin outcomes, or gut issues and near infrared light, or brain degeneration and longer wavelength near infrared light. It really depends on the user in those cases.
Is combining red light therapy with laser therapy more effective at treating pain than red light therapy alone?
So red light therapy can include either LED-based red light therapy or laser-based red light therapy. Lasers are collimated beams of light. So instead of a LED that emits a cone of light that is spread over a wide area, lasers emit a beam of light that can be very targeted. Since 1960, red light therapy sort of became first used in the context of using it with lasers, because that's what was available at the time. Now you'll see very few laser devices relative to the amount of red light therapy LED-based devices, for a good reason. LEDs are less expensive, they're safer to use. The risks of using a laser, as far as burning and eye damage, are not negligible, and you must take precautions when using any laser-based devices. Whereas LEDs are very family-friendly, are very safe to use, are very simple to use, and in the vast majority of contexts are the ones that you'd prefer. In the small minority of contexts, when you want to have a very targeted use, especially somewhere deeper in the body, lasers are what are typically then preferred. But in a sentence, LEDs are great for general use of light spreading over the body, and lasers are used for precision targeted treatments deeper in the body.
Do high energy devices require ventilation?
So the more power you're running through a device, the more heat dissipation that you'll need. So if you're running 1,000 LEDs in an enclosed device, you'll need to have airflow through that device so that the LEDs don't overheat. So generally speaking, higher devices require ventilation, and lower energy devices might just have the ambient environment be enough ventilation. With that said, you might see some panels that use active cooling of fans. You might see some panels that use heat sinks. And you might see other devices that don't need active cooling or heat sinks because their power output and size allow them to be not needing anything beyond the ambient environment. What's important to consider as well is that there's a sound associated when you're talking ventilation. So big, large devices that use fans are going to have a sound and a whirring of the fan while you're using them, whereas smaller devices can be completely silent. Personally, I like devices that are completely silent, even if I'm using all parts of the body, because that can become an annoying sound after a little bit of use.
Does a higher heat aid recovery? So the hotter the device, does that help in any way in recovery?
Heat in this context can be thought about two different ways, which is heat that the device is emitting in the near infrared range, and heat the device is generating sort of out of the back as a waste heat. So higher amounts of near infrared light aid recovery in the same way that higher amounts of red light to achieve the dose that you want are aiding your outcomes. So a higher amount of waste heat as ventilation has really no impact on the user, aside from it being sort of a reference point as to how high the power output is. That is to say, if you need a very, very high energy device, it's probably by definition going to emit a very high amount of waste heat that will be ventilated away. And so there's a correlation between the amount of excess heat the device is producing and the amount of power output that the device has. But that's would be a very difficult metric to use when making a decision, because there's many factors that can affect the heat dissipation. Generally speaking, higher quality devices will already take everything that I'm saying into account, and will try to maximize heat dissipation and minimize sound and minimize sort of strain to the user. So it's a little bit of a it depends answer. Higher near infrared heat is beneficial when you're trying to maximize your near infrared dose.
Will Lumaflex Body Pro's effectiveness be affected when used underwater?
So use underwater, it depends. If you're directly against the skin, then there should be really no difference between outside use. You know, if we're talking a vacuum seal, but I'm assuming a vacuum seal, so press right up against. Whereas if you're further away in water, you're going to have different types of refraction and reflection of the light before it impacts the body. So generally speaking, when the device is directly against the skin, whether you're in a water environment or whether you're in an open air environment, there's going to be there's going to be a negligible amount of difference in those two use cases.
Are there any specific benefits of using red light in water?
So I've never heard of a benefit of using red light in water outside of ease and accessibility. So if you're already in the shower and you want to use your device in the shower, then the benefit of using it in the water is that it's convenient to you. not that you're getting more benefit out of the device, but that it's more accessible. It aligns to your routine better. And so if it's getting you to use the device more consistently, then that's a benefit. If that means you're using it consistently in the shower, and to that customer, that's a benefit.
For arthritis pain, what wavelength is recommended?
Yeah, so generally arthritis pain, as far as I've seen in the clinical data, we're looking at 810, 850, 910, 950 for the near infrared wavelengths that are best for arthritis. You can find clinical studies and anecdotes where people have used any of those wavelengths and found immense arthritis recovery, including, of course, the addition of red light as well, because typically when you're using those wavelengths, you also have some amount of red light. But between 810, 850, 910, 950, I wouldn't say there's a clear scientific consensus, or if there ever would be a clear scientific consensus on which one is best. One way of viewing that is the sun. What red light therapy is mimicking, right? The red and infrared outputs of the sun include a smooth spectrum of all these near infrared wavelengths from 810 to 950 and up. And so, a combination of all four would have impact. One alone has already, of course, been shown to have a meaningful clinical significance. So I think a jury is still out on what is the best specific wavelength as it relates to arthritis.
For menstrual pain, what wavelength is typically recommended?
Yeah, so menstrual pain is sort of similar to arthritis. Here we're talking about a key factor being the depth of penetration. And so in that, we're looking again at this 810, 850, 910, 950 range, which is typical in your red light and near infrared light therapy device. But sort of the same answer as it relates to arthritis. All of those wavelengths, you'll find benefit. A combination of all four, you'd find benefit. You'll probably find clinical studies that are using various wavelengths in this range that all show benefit. And so there's no sort of one best. I know some people say 810 is best or 950 is best, but I think you can. I think even a combination might be best. I don't think that anyone has really had a particular reason to say that anyone is best in the near infrared range versus the others. We can get specific about chromophores and about specific types of absorption bandwidths of specific organelles in the body, but I think that gets a little bit too a reductionist, a little bit too technical, when I could generally say to someone suffering menstrual pain that a near infrared device with wavelengths between 810 and 950 are going to be beneficial.
How often should I use red light, and at what frequency? How long does it take to see those results when using it?
So use case, typically we're looking at once a day, but it sort of depends on user, what they're using on. So once a day can be interpreted several different ways, because you can do it once per day per treatment site. So if you have two bad knees and a bad back and a bad neck, you might use it 4 times a day, but once per day on each site. One of the beauties of red light therapy is it's not like a drug where you actually, if you took too much, you overdose. The analogy I like to pull with red light therapy is it's like dipping a sponge into water. Once the sponge is saturated, you can leave it in the water, but it's not going to absorb more water up. Once you pull it out of the water, or once you remove the body from the red light, then the body is using that energy to facilitate the healing, or that sponge is drying and it's releasing that water back into the environment. And so generally speaking, now it depends on the device, it depends on the user, but generally speaking, once a day per treatment site would be my generalized recommendation.
And how long does it typically take to see results in a general sense?
So results are user dependent as well as use case dependent. So things like pain relief. I've seen people have incredible pain relief stories just in one session after 10 minutes. So things that are associated with inflammation, like pain, happen very quickly because the reduction of inflammation happens very quickly. Now, things like hair growth, which require the new cells to be grown, take much longer. Talking weeks to months in scale versus 10 minutes in scale, and kind of everything in between. So if you were to make a spectrum, I would say the fastest things are the benefits seen by reducing inflammation, such as pain, and the longest things are the benefits seen where you need to have new cellular growth, such as things like hair growth or reducing wrinkles. And then in between those spectrum, you have sort of everything else that red light therapy can be used for.
Are there any side effects to using red light, especially at higher wavelengths?
An incredible part of red light therapy is that there's no negative side effects associated when you're using the devices correctly. Now, there's rare conditions, it's like hypersensitivity to light called porphyria, where people have hypersensitivity to light. And as you can imagine, if you're hypersensitive to light, then using a light device has different considerations than the average healthy general public that doesn't have porphyria. Longer wavelengths of red light, so as we get into near infrared and then middle infrared and far infrared, our body feels and absorbs this heat. So of course, if you're overheating the body, this can have negative side effects. If you're using devices as they are recommended, then you're not going to run into this overheating issue. But if you are using infrared and you use it much longer or at a much higher power output than is recommended, you might find that your body is overheating. And if you're overheating, then that's a negative side effect of the use. And that can affect other aspects of your health. If you get a burn, for example, that was a negative side effect, but it wasn't as negative side effect of using the device correctly. It was a negative side effect of projecting so much heat at your body that your body suffered a burn. With that said, these are generally speaking FDA cleared devices that don't have negative side effects associated outside of these populations that have hypersensitivity to light.
Can red light be used by everyone, including children, pregnant women, and animals?
Yeah, so red light, much like walking out in the sun, red light's already present in our environment, so you can definitely use red light, whether you're a kid or a cat and a dog and a pet and an animal, or a pregnant woman. This is a very gentle therapy as it relates to, especially relative to the therapies we're used to. So another way of framing that question could be like, can anyone walk in the sun? And it's like, well, of course, anyone can walk in the sun. You need to be conscious of, how sunny it is and how much UV light is present, because you want to avoid getting overexposed to the UV light of the sun. But yes, everyone can walk in the sun, including pregnant women. Now, of course, the sensitivity to the sun and by extension to red and infrared light may vary in these populations. But generally speaking, it's very gentle, it's very safe. I would pull the analogy of, can everyone drink water and become hydrated? Yes, everyone can drink water and become hydrated, but a kid needs less water than your cat or a dog or a pregnant woman. So it really depends in those specifics there.
Cool. Can red light penetrate through clothing or other materials?
Yeah, so red light penetrates clothing. Of course, it's also an it depends answer, because some clothing that is very transparent and very see-through will let a large amount of red light through, whereas clothing that are thick and dark, like a pair of blue jeans, are going to let only a very small amount of red light through. What's cool about red light and just the study of light in general is you can kind of see this per material. So if you take your phone flashlight and you put your finger over the flashlight, you'll see red light coming out. And this is because the red light wavelengths pass through the finger, whereas all the other colors contained in the white light are absorbed by the finger. So you could use a similar principle to test your clothing. You can hold up your red light therapy device to your shirt, and you can see visually how much red light is coming through. Of course, to measure that requires some equipment, but to see that difference, you might say it's about half as bright. Great, you probably have about half as much red light coming through that clothing material. With all that said, using red light therapy devices on bare skin is best, because the recommendations that the company you're getting it from are generally going to be assuming bare skin contact. And if you have clothing over, while it still can get through, bare skin is going to be the best use case.
What are the differences between red, near infrared, far infrared, and their respective effects?
Yeah, so the differences come down to the wavelength and by extension then the frequency. So red light falls in the 630, 660 nanometer wavelength range. Near infrared from the 800 to about 1,000, 1,100 would be your near infrared range. And then infrared's a very wide category relative to visible spectrum, but that goes all the way up to the thousands of wavelengths that you'll find in things like far infrared saunas or far infrared heaters. The effects are typically the same between these wavelengths of red and near infrared, but the penetration depth is the difference. So both red and near infrared increase blood flow, reduce inflammation, and increase cellular energy or ATP production of the mitochondria. But red light focuses the energy on the top surface of the skin, only about a centimeter into the body, whereas the near infrared wavelengths penetrate deeper in. So red light's better for things like skin, hair, topical impacts. Near infrared is better for things like musculoskeletal, and then longer wavelengths can bypass the skull and help and assist the brain. But the benefits are generally the same, and that's that increased blood flow, reduced inflammation, increased ATP.
Lovely. For red light devices, what is the difference between FDA certified and non-FDA certified ones?
Yeah, so FDA certified come down to the manufacturing partner that the device is coming from. So if the device is a medical grade facility with FDA clearance, then the devices that they're making are FDA certified or FDA cleared. Now, where this runs into a little bit of confusion is there's a difference between FDA clearance and an FDA approval. So if you want to say that my device treats a specific disease, then that requires an FDA approval. Whereas if you say my device is safe and it's built in a medical facility that's FDA cleared, that's something that is a regulation that governs the manufacturing partner, separate than the clinical trial and the data needed for FDA approval. So what's beautiful about red light therapy is because it's so safe and because it's now becoming so accessible, you don't need an FDA approved product to use it on your specific disease. So if you find a clinical study talking about the disease that you have and you see how that's been working and functioning, and there might not be any FDA approved products for that disease, but there's plenty of FDA cleared products that can give you the same exact irradiance, power output wavelengths that are shown in a clinical study. And so that's kind of the distinction right now in the marketplace. I think what we'll see is every year there'll be more and more products getting more and more FDA approvals for specific diseases. But right now, FDA cleared devices can still give you amazing outcomes on specific diseases. The companies in their marketing just can't say that, which is kind of this interesting world we live in, where you might have something that can really, really help somebody's disease, but you can do everything to help them except say this helps your disease. I understand why we live in the sort of a biochemical drug paradigm where there are really important reasons that's in place. But if we're using the analogy that red light therapy is like hydrating yourself with water, I think it's a little bit silly that if I see someone struggling with a specific disease, I can't actually speak to them in a scientifically accurate way because the regulations get in the way. But I think that that's something that will change over time as we systematically have more and more FDA approvals of red light therapy devices.
Last question, does skin color affect the absorption of red light?
Yeah, so skin color, another way of saying skin color is the concentration of melanin in the skin. And melanin is this really cool molecule that can really be thought of as solar panels in the skin. We're typically talking about melanin as a UV light sunscreen, which it is. It does block UV light from harming the body, but that's only a very, very small amount of things that melanin does. Melanin, when mixed with water in our cells, can be understood as like a biological solar panel that intakes light, stores it as electricity, and our body then uses that electricity. And so skin tone or melanin concentration does impact your ability to receive red light therapy. The darker someone's skin is, the more melanin they have, the more light they can receive to receive a larger and more pronounced benefit. So if you're somebody who's very pale, then you might only need, I'm making up numbers, but 5 joules of red light for your skin outcomes. Where if you're someone who's very dark, has lots of melanin, 5 joules will still be good for you, but you might have an upper capacity of 15 joules, and therefore a 15 joule dose is better for you than the 5 joule dose of someone with pale skin. So skin color does impact the benefits you can receive, and in a general blanket term, the darker the skin, the more light therapy you can do before your effects are sort of saturated.
Cool. That's it.
Lovely.
Thank you so much.
My pleasure.